Hi, in this Scribblecast video, we are going to be looking at solving equations. And really, we're reviewing principles that you know about solving equations. But um, as we go through those, make sure you focus on what that principle is. And you'll see later in the course how we'll use that principle to solve maybe different types of equations. So we're going to be looking at like a linear equation, a quadratic equation. In this course, we'll also look at trigonometric and logarithmic and exponential and lots of different types of equations. All of them, though, as you're looking at them, when you look at a linear equation or a quadratic equation, there'll be different ways to solve those. Like linear equation, you might use rule number 2. And quadratic, you might use rule number 5 or whatever. But there's different ways that you can solve each type of equation. Certainly there's similarities in each of them, but you need to know the principle that you can use with each different type. Okay, so the first one, the first principle is called the addition principle. And it basically says if you've got something equal to something else, so if A is equal to B, then if you add something to the A side, then if you add something to the C side, then the equality is maintained. And that's the key thing. So, for example, if I have x minus 3 is equal to 10, and I want to solve that, you can probably see that x is 13. But to use the addition principle, what I can do is I can say, okay, well, I have x minus 3 here, and I have 10 on this side. But really what I want is I just want to get an x on this side because I want to solve for what x is. So I want to get rid of this negative 3 or the minus 3. So a way I can do that is then I can add 3 because a negative 3 plus 3 gives me 0 and x plus 0 according to the additive inverse, or no, the 0 property for adding, x plus 0 is just x. But I can't just willy-nilly add a 3 here without doing it on the other side. That's the addition principle. If I add something on this side, I can add something in this side, and the quality of the two expressions are or is maintained. Okay, so on this side I'm left with x. On this side I'd come up with a positive 13. That's the addition principle. Here's a couple that you might want to try. Maybe press pause and try and solve both of these and see what you come up with. Okay, hopefully you've pressed play. In this one here, it's x plus 6, so I'm going to subtract 6 on this side. Notice that with the addition principle, you can say add a negative 6, so it's adding, but you can also subtract. If you subtract 6 on this side, you have to subtract 6 on this side. This is a short form of doing it. If you wanted to write it out as x plus 6 is equal to 11, and then on this side write a minus 6, and then write on this side a minus 6, you can do that. These will cancel, leaving you with an x. 11 take away 6 is 5. If you wanted to use a short form where you just 6 take away 6 is 0, so you're left with x equals 11 take away 6 is 5. If you like doing it this way, that's fine too. Okay, this question, this one looks a little bit dicier because I've got more things than before, it seems, or maybe more negative signs. Okay, so I want y by itself, side by itself. So I have a negative 15 here, so I can add 15. If I do it on this side, I have to do it on this side. So these cancel. I'd be left with a negative y is equal to 12 plus 15 is 27. But really, I don't want a negative y is equal to 27. I want a positive y. So I could do something different there, or I could use the addition principle again. If I wanted to, I could say, okay, what's a minus y? Let's add y on this side. If I add y here, I have to add y on that side. On this side, these would cancel, so it would be 0 is equal to 27 plus y. And now you've probably seen where I'm going here. I want y by itself, so we'll get rid of the 27. So subtract 27 on this side, subtract 27 on that side. So I get y is equal to a negative 27. You could have done a different rule right at that point here, but using the addition principle would still work. Okay, the one that I was just referring to is known as the multiplication principle. So it means that if I have an expression A and it's equal to an expression B, if I multiply A by something, As long as I multiply the other side by something, the two expressions are still equal to each other. And we use that all the time when we're solving equations. So for example, I have 4x is equal to 9. So if, I'm just going to rewrite that, 4 is that x is equal to 9. So if I want to use multiplication principle, what I could do is multiply this side by a quarter. If I multiply this side by a quarter, I can multiply that side by a quarter. The two expressions will be the same. A quarter times 4 is 1, so this will just be, on this side will just be x. 9 times a quarter is 9 quarters. So that would be my answer. Typically, you've probably seen this question done like this, though. 4x is equal to 9, so I want to get rid of the 4. It's being multiplied by the x, so I'll divide this side by 4, divide this side by 4. So x is equal to 9 quarters. Notice it's the same answers I got there. Either way, both of these are fine. This one here, I might, instead of calling it the multiplication principle, I might call it the division principle. Okay, so this one here, you can press pause and try it if you want. With this, for me, I would just divide this side by -3, divide that side by -3. They cancel, or it's a factor of 1, so they're eliminated. So y is 15 divided by -3 is -5. So that'd be my answer for that one. Now, if I needed to put the principles together, typically we use the addition-subtraction principle first, and then use the multiplication-division principle second. So here I want to get x by itself. First is get rid of this 4. So I'm going to add 4 to both sides. Notice there I skipped that step. I didn't write anything in there, but I knew that I had to add 4 here and add 4 there. I just kept that in my head. These cancel. Plus 4 minus 4 is 0. 0 plus 3x is still 3x. And then I added 4 in my head on that side. Now I'll use the division principle, divide both sides by 3. I come up with 17/3. If you need to put all those steps in between there, go ahead. Nothing wrong with putting steps in. Shows that you know what the principles are. This next one, I need to get x's by itself, but this time I have 2 x's. So I'll bring both x's together. So it'll be negative 8x, that's this one. If I bring this to this other side, I have to add 8x to both sides. Okay, 8x to both sides. Is equal to, 14 is there already. 5, if I subtract 5 on each side, that should balance things out. Notice I'm doing a ton of things in my head there, but I'm following those rules that we just looked at. Negative 8x plus 8x gives me, 0. Oh, no more x's. Whoops. Is equal to 14 take away 5 is 9. This is an interesting equation because when you solve it, all your x's go away. Two things can happen when your x's go away. You can either get a true statement or a false statement. When you look at this, is 0 equal to 9? It's not, right? So 0 is not equal to 9. Therefore, what I'd say for this equation is that there's no solution. If I came out at the end of something, I'll just do it in a different color. If I came at the end of something, and so I had x's and numbers and equal sign and whatever in there, if I came out to what happens to be a true statement, like 4 is equal to 4, if all my x's go away and I'm left with 4 is equal to 4, if that's a true statement, then the answer to whatever the question was originally would have been all answers are a solution. All answers are a solution. So you could plug anything in for x and you'd come up with a true statement. Okay, one other thing with linear equations that sometimes we run into is something called, I call it a dirty, rotten, filthy, stinking negative. And I can recognize that anytime there's a negative sign out front of a bracket. And that typically messes students up a little bit. But here's how you can deal with it. You just have to remember that that negative sign applies to everything in the brackets following it. So if I were to eliminate the brackets and simplify this, I'd put a negative to the 3x would be a negative 3x. This is the one that many students forget. And negative times a negative, this would be a positive 5, is equal to 40. So these two signs here, you've got to get right. If you get them wrong, then you're letting the dirty, rotten, filthy, stinking negative get the best of you. Okay, then to solve this, gather my x's, put the 5 to the other side, divide both sides by 5, I come up with 7. Try that next one. It's got a dirty, rotten, filthy, stinking negative right there. Press pause and then press play, see how you do. Okay, I would write 21x plus 6 times 7 is about 42 is equal to 11. And then this is, I have to change that sign so it's a negative x, and I change this sign so it's a negative 2. Now collect like terms. At 21x here, a minus there. If I bring it over, this would be a 22x is equal to 42 to the other side is a negative 42. If I subtract 42 from both sides, so on this side I get negative 44. Dividing both sides by 22, I get a negative 2. So that'd be answer for that question. Okay, so hopefully you're getting the idea with solving those equations. And these are all rules that we can use with lots of equations, but these ones are specific to linear equations. Now let's turn our attention to a rule that we can use for quadratic equations. It's called the principle of zero products. Its basic thing is, if I've got two things and when I multiply those I come up with 0, then one of these original things had to have been 0. So if I say had x times y is equal to 0, then it's either x has to be 0 or y has to be 0. Okay? Either of those things, a 0 for x or a 0 for y, would make that statement true. Now, if I had something in brackets like this, x minus 2 times x plus 3, so here's two things that I'm multiplying together. If they come out to 0, then I can do the same thing. So either this first part 0 or the second part 0. And I could write that. Either x minus 2 is 0 or x plus 3 is equal to 0. Now suddenly I have two linear equations that I could solve. Add 2 to both sides, subtract 3 from both sides. So in this question right here, I have two answers. X could be a 2, that would work, or x could be a negative 3, that would work. I would get 0 out of the product of those two. Now I use this rule lots when I have quadratic equations, something that I can factor into two different factors. So let's try a couple. Here's an equation. This one, it doesn't look right because it doesn't equal to 0. Anytime you have a quadratic, you want to make it equal to 0. So x squared plus 3x minus 28 is equal to 0. Now what I want to do is get these two things, or this thing, these three terms, it's a quadratic, I want to get it into two brackets. Because if it's in two brackets, then I can use that 0 property we were just talking about. So two things that multiply to negative 28 add to the 3. I think 7 and 4. So x plus 7, x minus 4. If you FOIL that out, you'll find it gives you this. But the point we're trying to make with this one is that here I have two things. This times this equals 0. One of them's got to be 0. So either x plus 7 is 0 or x minus 4 is equal to 0. In this case here, if I solve that equation, x comes to negative 7, and here x comes equal to a positive 4. So those two numbers are solutions to that equation. If you wanted to take, say, the 4 and plug it in everywhere you see an x, so 4 squared plus 3 times 4, you'll see that hopefully gives you 28. We'll see. 4 squared is 16, 3 times 4 is 12. When you add those together, sure enough, 28 means x equals 4 is one of your answers. Here's another one. This doesn't have a third term like the one up above, but I can factor a common factor out of that. So it'll be an x times x plus 7 is equal to 0. Again, I have two things that multiply together to give me 0. So x equals 0 or x plus 7 is equal to 0. 0 would be one of my answers, and here I'd have to subtract 7 from both sides. So x equals negative 7 would be my second answer that would make this statement true. Okay, here's another one. Here's one where I have a 3 in front. That means it's an AC thing. I'm going to have to factor that. I'm just going to try and see if I can guess it. So I'm calling it that a 3a and this an a. And then if I put a plus 2 here and a plus 2 there, I think when you FOIL that out, you'll find that you come up with this. Okay, and that's equal to 0. This times this equals 0. That's my 0 property. So either 3a plus 2 is 0, or a plus 2 has to be equal to 0. Solve each equation. Move the 2 to the other side. That'll become a negative 2. Divide both sides by 3. So my first answer is 2/3. That's one answer that would work to make this statement true. Over here, I'd subtract 2 from both sides, so I get a equals negative 2. Then that would be my second answer, that if I plugged it in wherever there's an a, it would make that statement true. Okay, so that's known as the 0 property. Two things multiplied together give me 0. One of them has to be 0. Okay, the last principle we'll look at, I think, is something called the principle of square roots. So if I have x squared is equal to k, for example, then if I want to solve for x, what I can do is square root both sides. And when I square root both sides, on the right side, I've got to make one of them positive and one of them negative. Let me give you an example. If I have x squared is equal to 16, for example, ask yourself, what can you square to give you 16? Of course, you're thinking 4, but also it could be a negative 4, because if I have negative 4 squared, that also gives me a positive 16. So to solve this, what I do is I say, okay, x squared is equal to 16, so I'm going to take a square root of this side. Square root of this side will knock this down to just a plain x. But if I square root this side, I have to square root this side. The square root of 16 is 4. The last thing you have to worry about every time with this principle of square roots is that because there could be two answers, this could be a plus or a negative. So my answer to that question would be a positive and a negative 4. Try a couple. With this one, let's maybe isolate the x squared. So I'd call it x squared is equal to 9 over 18. Then maybe I'll simplify that. 9 over 18 is equal to a half. Now I'll use the square root principle. Or maybe do it up here. So it'd be x squared is equal to a half. So I'll square root this side. That'll leave me with just an x. Then I'll square root this side, making sure I put a plus minus there. It'll be the plus or minus square root of 1/2. You can do some simplifying with that, but we'll do that when we get into radical equations. Here's the last one. Divide both sides by 2, so you get y squared is equal to 10. Then square root both sides, so you get your answer would be plus or minus square root of 10. Okay, this is the last thing, I forgot about this, is oftentimes we have an equation where we're not actually solving for a number for the equation, but we're manipulating the formula so we sort of solve for one of the particular letters. And then after that, that's when we plug numbers in. So if I need to solve for a variable, in this case I have to solve for a in this equation, I'd want to isolate a. So the first thing I do is get rid of this by. So I'd leave ax where it's at, leave c where it's at. This one I'll subtract by from each side. If I subtract it here, they cancel. And on this side, if I subtract by, I get that. Now I want to solve for a, so I don't want ax, I just want an a. So I have to get rid of this x. Since it's multiplying the a by x, I can divide everything by x. So I'd get a is equal to c divided by x minus by divided by x. So this would be the expression that I would say would be this solved for a. Here's another one. I have to solve this variable for y. Problem that I have with this one is that there's two y's. So there's one trick you can use to solve this one for y, and that is get the y's together. So I'll move the y to this side. So it'll be xy negative y is equal to negative 5. And then the trick with this is if you have two of them, to get one, what you do is you factor. So I can factor a y out. With this one, I'll be left with an x. With this one, y divided by y is a 1 is equal to negative 5. Now I just have one y there. So if I want to solve for y, I'll have to get it by itself. Since I'm multiplying by x minus 1, I'll just write it all out here. That's a negative 5. I'm going to divide this side by x minus 1 and divide this side by x minus 1. So these will cancel. I'll be left with y is equal to negative 5 over x minus 1. Okay, so that is a bunch of solving equations. Hopefully it's review. If it's not, maybe practice some of those questions from the textbook or from other sources that you have.